Lesson 93, two-step equations and inequalities. Since Investigation 7, we've practiced solving one-step balanced equations. In this lesson, we'll practice solving two-step equations. This balance scale illustrates the two-step equation. If you notice, we have the two x's here, and then we also have the 5 on this side, and we have 35 on this side. And so 2x plus 5 equals 35 is what the equation looks like. And on the left side, we have two different things. We have 2x and 5. And so to solve the equation, first we get the variable by itself, or isolate the variable. And so this is always what we're doing even in one-step equations, is isolating the variable. So we isolate the variable by subtracting the 5, or adding -5 to both sides, however you want to look at that. And so they show that here. And so here's another way to show that. 2x plus 5 equals 35. And we're going to minus 5 from both sides. And notice we're minusing 5 from the 5 because -5 and +5 cancel out. And that's really the whole point of this, is to take it off of one side and put it on the other. So then we're going to rewrite this equation for our next step by crossing out those 5's because they cancel out. And so 2x equals 35 minus 5, which is 30. And so that's where they got this 2x equals 30 simplified. So really, this is just like the one-step problems we've done before where we've had addition or subtraction. But now, we still aren't done with this equation. We still have those 2x's equaling 30. And so we have to divide both sides by 2 because we have 2x's. And so when you divide both sides by 2, then you get x equals 15. So again, I'm going to show that up here. We divide both sides by 2, and x equals, because those cancel to 1, and 1x equals x equals 15. Okay, so when we write and solve these equations, we're going to be solving them using 3 steps, or 2 steps now, and the third step is the answer. So if we start out with 2x plus 5 equals 35, the steps that you need to show are minus 5 from both sides, and then rewrite your equation, 2x equals 30, because these 5's canceled out, and 35 minus 5 equals 30. Then show dividing both sides by 2. And so x equals 15. Last thing you should always do is check your equation. So does 2 times 15 plus 5 equal 35? Yes, it does. 2 times 15 is 30, and 30 plus 5 is 35. So you should always check those to make sure they're correct. So here's another one. This one happens to have decimals in it. Doesn't change how we do the problem. Where's the variable? Here it is. What's added or subtracted to it? What's added in this case is a plus 1.2 or a positive 1.2. So we need to do its opposite. So we're going to minus 1.2 from this side of the equation and from the other side of the equation. And I'm going to make this 6.0 so I can do that subtraction. So I'm going to borrow from the 6. And so that's 8, and this is 4, so 4.8. So I'm going to rewrite my equation now. 0.4x equals 4.8. Because positive 1.2 and negative 1.2 cancel out. And always that's going to happen. That's the whole purpose of the equation, is to take something off of one side and move it to the other by doing its opposite. And then here we have 0.4x, so we're not done yet. We don't have x by itself. So we need to get rid of this 0.4x, and it is multiplied. And so we're going to divide by 0.4 on both sides. We always want to leave the x there. We don't want to divide by 0.4x because we want to leave the x by itself. And so when we divide by 0.4, that makes that a 1, and so that's just x equals, and then we do the division. 4 divided by 4 is 1.8. 4 divided by, oh, I thought that was just a 4. We better take into account the decimal here. So 4.8 divided by 0.4. I'm going to move my decimal back. So 4 goes into 4 once, and it goes into 8 twice. And so that's really going to be 12. And so let's check our equation again. 0.4 times 12 plus 1.2 should equal 6. So I'm going back to that original equation that they gave me. 0.4 times 12 is 4.8. 4.8 plus 1.2, does that equal 6? Well, yes, it does. 4.8 plus 1.2 is 6. So I checked the equation. I made sure it was correct. So here's another one. Solve this equation. Again, the equation doesn't change how we solve it, whether we have decimals, fractions, or whole numbers. So where's the variable? What's added or subtracted to it? And now we have a minus 1.2 or 1/2 there. So we are going to add 1/2 to both sides. Why add 1/2? Because negative 1/2 and positive 1/2 is 0. And we have to do it to both sides of the equal sign. So I'm going to rewrite my equation now. Negative 2/3 x, because these cancel out, equals, and now I have to add these together, so I need a common denominator. 1/3 times by 2, so that's 2/6. 2 times 3 is 6, so times by 3 here. And so 2/6 plus 3/6 is 5/6. Okay, but I'm still not done because, again, x is not by itself. So I have to multiply by the reciprocal here because this is multiplied, but when I divide by a fraction, I always multiply by its reciprocal. So negative 3/2, and I have to multiply by negative because I don't want to leave a negative x there. And so I'm going to multiply both of these together, and I'm going to get positive 1x. But if I do it to this side, I have to do it to this side. And so is there anything that cancels? Yes, there is. 6 and 3. And so I get a negative, because negative times positive is negative, and then 5/4. And so let's check that. Negative 2/3 times negative 5/4 minus 1/2 should equal 1/3. And notice I left this an improper fraction, and I did that because when I put it back in, I want to be able to do some, I'm going to just put this up here. It looks, can't tell that that's a negative. So negative times negative is positive, and I can do some reducing here, so that's going to be 5/6 minus 1/2, which I'm going to change to 3/6, which ends up being 2/6. So 5/6 minus 3/6 is 2/6. Is 2/6 equal to 1/3? Yes, it is. So I know that I've done this problem correctly. So it doesn't matter whether it's decimals, fractions, whole numbers, we do the same steps. All right, so where's the variable here? The variable happens to be on the opposite side of the equation that we've done all the other problems, but it doesn't make any difference. You find the variable, find what's added or subtracted to it. That's the positive 6. So we have to do the opposite of plus 6, which is minus 6, or negative 6. And so we're going to put the negative 6 over here, and then we're going to rewrite this equation. Well, be careful here because negative 15 and negative 6 adds up to negative 21. And so we have these 6's canceling out, and so that equals 3x. And then, again, we don't have our variable by itself. Here's the variable. We need to get rid of this 3. It's multiplied, so we're going to divide by 3. And so that cancels out to 1. So x equals negative 21 divided by 3 is negative divided by positive is negative. 21 divided by 3 is 7. So x equals negative 7. Now, this thinking skill over here, it says interchange the sides of the equation. Why will the solution remain the same? So if I did 3x plus 6 equals negative 15, is that going to change what answer I get? And no, it's not. And the reason for that is because of the commutative property says you can do either side. It doesn't matter, equal sides. X equals 6 and 6 equals x. Those are the same thing. Let's check our answer really quick. 3 times negative 7 plus 6 should equal negative 15. And is that true? Negative 21 plus 6 equals negative 15. Yes, it is, so we know we got the correct answer. So, solving inequalities. Inequalities work exactly the same way as solving regular equations. So we're going to treat this almost like it's an equal sign, and we're going to follow the same steps. And so here we have 2x minus 5 is greater than or equal to 1. And so, again, find your variable, what's added or subtracted to it, negative 5, so we're going to plus 5 or add 5 to both sides. And so I'm going to rewrite this equation. Those cancel out. 2x is greater than or equal to 6. And one last step, it's still not x by itself, so I have to divide both sides by 2. And so x is greater than or equal to 3. And then I can graph that. 0, 1, 2, and 3. And greater than or equal to 3 means we're going to fill in this circle because it's equal to, or it's greater than. And greater than going to the right. Again, filled in if it's equal to, if it has this equal sign on it, it's filled in, and if it doesn't, then it's an empty circle or open circle. Your homework for this assignment is here on this last page. You're going to solve each equation, and you're going to show and justify all steps. In other words, show me each step as you do it, so you cannot do it on this piece of paper because you need more space, or you could do it if there's enough space below. I don't know how this will print out. But your assignment for tomorrow is just to do these problems, not the rest of the lesson.